For principle of thermodynamic and energy conservation, we use two type of equation, which is mass balance equation and energy balance equation. And the top one is the formula for mass balance equation, and the bottom one is at for energy balance equation.
So this is for our selected steady flow device. Introduction of heat exchanger evaporator. Heat exchanger evaporators are vital in thermal system for air conditioning, refrigeration, and industrial process. They absorb heat from liquids, promoting a phase change to vapor and cooling the surroundings. Typically constructed with tubes or coils, these evaporators ensure efficient heat transfers for temperature regulation. In refrigeration, they play a key role in absorbing heat from cold space, causing refrigerants to evaporate and cool the environment. The efficiency of evaporators directly affects the overall performance, impacting cooling capacity and energy consumption in thermal systems. So, for our operating system and mechanism, the evaporator turns liquid refrigerant into vapor by soaking up heat from around it. This change happens at a steady temperature and pressure, making cooling effective. Coils or tubes in the evaporator spread out to touch what needs cooling. Liquid refrigerant comes in through a valve, turns into a vapor, and absorbs heat. The evaporator stays at constant pressure, keeping a consistent temperature for good cooling. In the refrigeration cycle, the evaporator comes after the compression and condensation, using pressure drop to soak up heat and turn refrigerant into a vapor. Superheat. The temperature difference in the evaporator needs control for efficiency. We control superheat by adjusting how much refrigerant goes into the evaporator. So, this is the key components for heat exchanger evaporator. Heat exchanger, separator, condenser, coils or tube, fins or plates, refrigerant inlet or outlet, expansion valve, fans or blowers, distributor, temperature and pressure sensors, drain pan, and lastly, frame or casing. So, for our advantage of heat exchanger evaporator, evaporators efficiently transfers heat from surroundings to fluids, enhancing cooling system effectiveness. Energy consumption is reduced as evaporators optimize the heat exchange process. Efficient heat transfers maintain desired temperature levels for specific applications. Low energy consumption makes evaporators cost effective and environment friendly. Temperature control is a key advantage, especially beneficial for prolonged food storage. Evaporators contribute to long-term preservation by regulating temperature effectively, ideal for application requiring stable condition over extended periods. Limitation of heat exchanger evaporator. Frost formation on the evaporator surface can reduce efficiency, acting as insulation and lowering heat exchange effectiveness. Refrigerant flow through the evaporator may cause pressure drops, affecting the overall system performance. Proper design considerations are essential to minimize pressure drop effects. Evaporator materials, if not corrosion resistant, can be prone to corrosion, and anti-corrosion materials can be expensive. The performance of evaporators can be influenced by variations in ambient conditions like temperature and humidity. Fluctuation in environmental conditions may lead to efficiency variations in the system. Limited space for the evaporator in some applications can impact the ability to achieve optimal heat transfer surface area. In multi-stage refrigeration system integrating heat exchanger, evaporators become more complex, potentially increasing cost and maintenance requirements. So this is the detailed explanation of a specific application. Our application is a refrigerator. The refrigerator's evaporators cools the interior, preserving perishable goods. Fin-equipped coils or tube enhance heat transmission in the system. Key components include the fan, expansion valve, and refrigerant pods in a closed-loop cycle. Warm air contacts the evaporator coils, causing refrigerant to evaporate and heat extract. This process lowers the temperature, extending the shelf life of our food. Freezer compartments in some refrigerators have a dedicated evaporator section for freezing. Defrosting mechanism prevent ice build-up on coils, ensuring continuous and efficient heat transfers. So, this is the benefits of implementing evaporator in the refrigerator. Refrigerator with heat exchanger evaporators precisely control temperature for effective cooling. In industrial process, they maintain optimal condition, preventing damage to sensitive materials. Consistent and controlled temperature enhance overall process efficiency. The heat exchanger evaporators efficiently absorb heat, crucial for stable lower temperatures. Cooling extend material or product shelf life, reduce waste, and improve the quality. Modern refrigerators have energy-efficient features, reducing operating costs and being environmentally friendly. So, for challenge of implementing evaporator in refrigerator, installing cooling units with heat exchanger evaporators in limited industrial spaces can be challenging. Designing and integrating this system is complex, considering factors like heat transfer efficiency and uniform cooling. Regular maintenance is necessary for optimal performance, with the complexity increasing maintenance demands. Initial costs for these cooling units, especially in industry, are significant, covering equipment, installation, and potential infrastructure modifications. Industrial refrigeration units may consume large amounts of energy, requiring a balance for cost and environmental impact. Excessive noise from refrigerators during operation can be concerned, particularly in residential settings.
For the case study area application of SSFD, our group have choose a refrigerator. So the evaporator is a crucial part that power of every refrigerator. They contribute significantly to the complex of heat exchanger that characteristic refrigeration, working diligently to keep your food fresh and drink pleasant. Invention a complex web of a cylinder, fins or tube tucked away inside the cool refrigerator. They are the battleground of the evaporator, where heat and cold combine to produce the refreshing atmosphere window. For the importance of the refrigerator, the evaporator is an essential part of a refrigeration system that takes heat from the air or a designed area. The refrigerant vaporizes because to the heat it absorbs, changing from a low pressure liquid to a low pressure gas. In the case, the refrigerator is a crucial component of the evaporator heat exchanger system. The refrigerator in the heat exchanger evaporator is a crucial for heat observation. The heat observation from the area being cooled is the evaporator main job. By letting the refrigerant evaporation inside the refrigerator aids in the process of the heat observation. In order to enable the refrigeration to constantly absorb heat and evaporate, the refrigerator has to maintain low temperature inside the evaporator. This is necessary for a refrigeration system entire cooling operation. The heat exchange process operates more efficiently when refrigerators are built and maintained appropriately. For the purpose of conducting a refrigerator, is to understand the system performance, the function of the refrigerator in the heat exchanger evaporator of a particular refrigeration system can be thoroughly examined using a case study. Next, the purpose is to study the efficiency evaluation of refrigerator, which a particular focus and refrigerators contribution to heat observation, phase change, and overall cooling efficiency. This case study make it possible to assess to heat exchanger evaporators efficiency. Another purpose is the performance comparison. Selecting the most efficient and effective configuration for refrigeration system or evaporation is aided by comparing their performance through case study. Next, continuous improvement is to find opportunity to enhance their refrigeration system by looking at a case. The process of a constant improvement has the potential to produce technologies. By looking at a case, the process of a constant improvement has to be potential to produce technologies that are both more ecologically friendly and efficiency. Next is a description of the application and system. A refrigeration system frequently have a heat exchanger evaporation system with a steady flow device. The system is essentially to the process of absorbing heat from a specific material or area, which result in the phase change of the refrigerant from a liquid to a vapor. The expansion device is a first filled with a high pressure, high temperature liquid refrigerant which start the operation. The steady flow device ensures a regular and effective heat exchange process by maintaining a constant refrigerant flow rate into the evaporator. The refrigerant in the evaporator can absorb heat from the environment. After absorbing heat, the refrigerant changes phase and become a vapor. After that, the compressor receives this vapor again for the subsequent cycle. Precise control over the refrigerant flow rate is made possible by the steady flow device, which is often an expansion valve, achieving in instant cooling effect and preserving system efficiency depends on this regulation.